Hi, my name is Isabella Formica. I'm in Dr. Jean's Section 2 lab on Tuesday mornings, and today I'll be showing you Experiment 6 lab report. For the abstract portion, the main purpose for this experiment is to figure out at what milliliters does citric acid affect lemon juice. To determine this, 3 beakers and a test beaker are used to a certain milliliter to determine each amount needed to neutralize the acid. The ability to see this occurs by adding a solution called sodium hydroxide. As a result of this, the solution should form a light pink color. As part of my results, the molarity of the standard sodium hydroxide solution is 0.0813, and then for my first table, all of our trials were about roughly the same. We determined that the rough trial was because it was our first start, was a little off than the others, but for the most part the rest were on point with each other. For the next part of the results, we have table 2, which is before the titration measured, and then table 3 after the titration was measured. For calculations and interpolations, questions 1 and 2, my balanced equation is here, the top in the red. And you have citric acid plus sodium hydroxide, which is formed to make sodium citrate and water. And then for number 2, the concentration of the citric acid. For trials 1, we have, and the molarity of that. And then for 2 and 3, we got the same answers. And the molarity for that. For calculation and interpretation, questions 3 and 4. For 3, the mean would be, you would add all 3 of them up and then divide by 3, and 0.260 would be my mean. And then for standard deviation, about all 3 of them turned out to be 0.004714. And then for question 4, the pH of the lemon juice mean, the before we added up all 3, and then at the end divided by 3 to get 2.65, and then the after we added up all 3 of them and then divided by 3 again to get 9.65. For discussion question number 1, I think if a student wanted to determine the acidity of a tomato drink, I think it would just be less amount of solution of sodium hydroxide and water to turn the solution at the bottom pink. I think this because tomato juice is less acidic and closer to the base than lemon juice is. So I would think if there was any sort of problem that would occur, it wouldn't be acidic enough to figure out the acidity of it. For discussion question number 2, comparing the pH values of the lemon juice before and after the titration with sodium hydroxide, I think the reason that the numbers have changed so much, my before solution titration numbers were between 2.6 and 2.68-ish, and then my after numbers were roughly between 9.6 and 9.81. I think that they changed so much because I think after you add water, it affects the pH level, and I think that it brings it to more of a base rather than it being more acidic. So I think that the additional water coming in changes. The before titration is at a very low number, which means it's more acidic. and then afterwards it's tested again and it's at a higher number. I think that the difference between the two, like I said, was the after titration is closer to the base level than the beginning one is. So for discussion question number 3, it's asking to determine 2 different reasons why manufacturers use phosphoric acids in beverages. According to Coca-Cola.com, they add phosphoric acid into theirs to create more of a tangy flavor towards their Cokes, and it also says on here that it is beneficial to our bodies and gives our bones and teeth like better structure. Personally, I don't think that phosphoric acid in large amounts is good for you, only because drinking some of the drinks pop, I feel like pop in general is not good for you, and anything that's added to it probably is not the best. But people do drink it, people enjoy it. It's not gotten out of hand by any means, so I think maybe having a little bit of phosphoric acid in pop is not a bad thing. Another reason that manufacturers put phosphoric acid in beverages like pops is because it prevents the growth of mold, and apparently in sugary drinks that mold can grow very fast and very easily. And I found this source from sciencing.org. According to healthline.com, phosphorus is needed in our body, but it is needed in small amounts, and obviously too much of it is not good, but you can't go without having any in your body. And also phosphorus is also very good for your teeth. It builds up the calcium that surround like the lining of your teeth, so it is also very good for that. But too much of it is not good for your health. Not enough of it is also not good for your health. Lastly is my list of references. The first 3 are websites that I used to answer this discussion question number 3, and the last source is the lab manual that I recorded all of my data in and found some other useful information on. All of my sources are credible, and they can be backed up either by a doctorate or some sort of scientist proven valuable.